Hi everyone, in this tutorial we will learn how to use the HydroEco long short-term memory for modeling hydroecological processes with long short-term memory neural network. So for more information about this package, you can read the package documentation in here or check the paper of this package here. And today we will learn how to model streamflow using this package. So first you need to install Anaconda and then use Anaconda to install this package by using the environment file in here. And you can see the tutorial number 1 and 7 in this link for how to install Anaconda and how to install a package using the environment file. So first, let's download this repository. Download. Okay, and extract here. You go to this folder, you will see the example and the environment file and the example data. For example, streamflow simulation, the data is in here. So let's open Anaconda here. Anaconda, and then you can install using the environment file conda here. But the link to the environment file is in here. So the environment file is in here. You just copy the path here and then paste it to this location. Yeah. Change this to /. Okay, and then you just execute this command. It will install the HydroEco long short-term memory environment, and it will also install Spider. So just enter. Okay, I already installed, so I don't need to enter in here. And then after installing the environment using environment file, you go to here and you will see that your Spider also installed in this environment. So I just click here. Of course, you can use other Python IDE. So just import HydroEco long short-term memory F9 and then HydroEco long short-term memory dot interface dot show interface. I want to show the interface F9 and then you will see the interface. So we need to import time series data for streamflow simulation, and you click here and go to the downloaded repository example data time series. This should be CSV file and the content. So you can open this file here. Example data, you can open here, right click, open with this, and you will see here. So it has the object ID column and the time. So these are must have columns. So must have the same name, object ID and time. The object ID in here, so it's and the separation by comma. And the object ID here is the catchment ID. It can be number or character. So here I have catchment ID 2009 and the time is year, day, month, day, and then space, and then hours, two dot, and then minute. And then I have discharge data. The discharge data could be in cubic meter per second or could be in millimeter per day. It's up to you. If you have the input in here is cubic meter per second, the output could be the same unit. And then you have for modeling stream flow, of course, we need precipitation in here. The unit is, can be any unit. And then I also have like other time series data. Not sure we need or not, but Here we have like temperature minimum, temperature mean, and temperature maximum, and other things. So your time series data should be continuous, yeah, except the target variable. And in here, my target variable is discharge, so I could have missing value. Missing value just empty. For example, here, the discharge here, if missing value, it's like this. Okay, and then I also have multiple catchment. For example, the first catchment, the time series up to 2020. Yeah. Second catchment could have checked ID 2011 and the starting time is the same. Ending time is the same. 2020 here. And so on. You can have many catchments as you want. And the time series here now currently should be the same from 2000 to 2020. And okay, and then I can show the data in here. I can plot it. For example, I can plot, let's say I want to plot this chart with object ID and click here, plot. And you can group by object ID, which is catchment ID and multiple subplot. And then here, so I have 1, 2, 3, 4, 10 catchments. The first catchment is the ID here and the discharge here. And you can do multiple things with this visualization, and then you can adjust the aesthetic as you like. So for more information about this, you can see the pandas table documentation. And okay, I'm going to use this for using this data for my model. And for static data, so it is catchment attribute or the average meteorological characteristic. And this is optional. So when you want to simulate for just single basin, you don't need static attribute because it's constant in time. But when you want to simulate for multiple basins, you need static attribute. So I select static attribute, click here and open. So here I must have the object ID. So for example, in here, sorry. So in here, I have the object ID 2000 and 2009, and here I have 2009 here also. So the object ID in here should be the same. Of the time series static should be the same. So the program know how to link the object ID in here with here. So for example, here I have the mean elevation, mean slope, and precipitation seasonality, aridity, and so on. And I'm also going to use this for my simulation. And now filter data, it means that you want to select which input and output for your model. For example, here, I want for streamflow simulation, I want to have a mean elevation, mean slope, precipitation seasonality, aridity, and potential evapotranspiration mean. And I'm not going to use this here because this will be my target variable. And of course, precipitation, and I just use mean temperature, and it's up to you. You can use more or less, just trial and error. And target variable, I want to simulate discharge, but you can also add a target variable, so you can have multiple target variables. And the object ID here, so just explain the input feature here is open this, and the program here import the column name here into this box, and precipitation also, and also the column of the static files in here, column names. Object ID I want to simulate for 3 catchments, and the training period here from 2000 to 2010, and validation from 10 to 15, and testing 15 to 2020. Okay, and then I need to transform the data. You can normalize using min max scalar, or Z score, or you just use the original value. It's up to you. Just try and error, and you will see if the model does not give good result, and you can change. Okay, let's say like this. And now I transform the data and also split the data into train, test, and valid. And I can see the data after transformation here. Okay, and network design. So here, just want to network design. So here we have the our network, our model model class in here. We have input and we have model class in here. You can see like, and this is long short term memory neural network, but you can have some variation of the long short term memory neural network with different name. And the model head, you can also how many layers in this model head, which kind of activation function, and finally the output. So input go into the model class, and then it feed into the model head, and then it becomes output. And here I want to have 30 hidden units for the long short term memory neural network layer, and I just have one layer for my long short term neural network. Normally one layer enough. The dropout rate is used to avoid overfitting. So I just, it could be 0.3 to 0 to 1. If you input something wrong in here, for example, if I type S, it will turns to red. Yeah. This also, for example, if I don't know, I just type A, it will be red. So here it should be integer or turn search space API command. So you can see in here. So you can input an integer, or you can input in here a command that tells this package to optimize. For example, let's search uh, the hidden unit of 10, 20, 30, which is the best value. Yeah, you can search in. But so for the first example, let's be simple. I have 30, and then model head. Model head just explained in here. So model head. This is the model head. How many layers do we want? For example, I could have one layer, and the activation of this layer is identity. Identity is mean that input equal to output. You can go to PyTorch and see what the identity mean, or sigmod or tang or soft plus function. Or I can have two layers. So you just need to define the number of neurons in the layer next to the last layer, because the number of neurons in the last layer is 1, which is equal to the number of target variable. Here we only have streamflow, so only 1, and you don't need to define here. For example, 3 layer or so, you just define the number of neurons for the first layer, second layer, the last layer. You don't need to define. Let's say, to be simple, just 1 layer. And training and testing. So load model, sometimes someone give you the model state index, and we can use this as an initial model static. Static is the bias and the weight of the model. But in here we don't have anything, just start from scratch. So don't need to input, it's optional. And the number of epochs, click here, it will explain you what is the warm-up length, sequence length, and batch size, which is common terms in machine learning in here. So for example, I want to have 100, or let's say 150. Oh, it's wrong. So it turned red. Okay, it's okay. Learning rate, let's say 0.001. Warm up. Warm up, for example, it's similar to physically based hydrological model. When we run the model, we need to leave out some of the first output. For example, I want to leave out the first output for the first 30 days because it's not reliable. It is affected by initial state of the model. Sequence length, let's say 1 year. Batch size, let's say 2. And then patient length, let's say 30. And then optimization method, I just say Adam and loss function in here, root mean square error, output. So I just say output in here, just select this folder. And now I just run the model. You can open here, see that it's running. So my average loss is for the training and for the validation, it is reducing. Okay, simulation is done. So just go back to here, close this, and you can visualize the result from the current project. So you don't need to click anything here. And let's plot the loss function for training and validation. Here I see that the training loss and validation are decreasing up to 150 epochs. So it means that we might need to increase the number of epochs in here because training loss and validation loss keep decreasing. And it's good when the training loss and validation loss are similar. So let's plot the time series in here. You can type the object ID in here. If you don't remember, you just click this. And the target variable, you just select it in here. Here, but you don't remember the name, you can visualize the result. You can just click here and then plot. So let's see here. I'll plot, and this is for the training, validation, and test. You can also optimize. You can change the appearance of this using the option in here. And you can also plot the next one, plot up here. And you see this for training validation loss. I want to increase the E limit, let's say 1200. And update plot in here. Yeah, so here it's higher. Yeah, you can see training validation loss for discharge. You can also change the label in here. You can see, if you click here, you can see your project summary and you can save it and later you can reproduce what you are doing. You can also can save everything, save all. For example, I save to here, result, select folder, save. And let's check it, result here, I just save it. So best configuration in here. This is my input data, static data file, output folder, and so on. The object ID. So, and then you can also apply this model for other basins. You can click here, internal import, so it will import all of the model and the data also from this file, this file, this file. And then you can select which catchment you want to test. For example, I want to test my model for the 3 catchment in here for the period from 20, let's say 2000, and then I run the model, finish run, and I visualize the result. So let's see here is application. So observe simulation. You can also change this. For example, I want to observe lifetime solid. Okay, plot again. And then here, yeah, you can zoom in also. Yeah, okay. And so this is the first tutorial about how to use HydroEcoLSTM long short-term memory for streamflow simulation. Please see the next video for other application of this package. Thanks for your interest in this video.